Hello, this video is to go through Module 6 notes that we took in class and then the review for the Module 6 test. So we have Module 6, this is Module 6, Lesson 1. We're going to go over vocabulary first. And we took these notes on December 2nd of 2025. So when we have something like this, we want to note that this, the floating number, right, is called an exponent. So the 4 is an exponent. It's very important that it's up a little higher than the variable, right? And then the x is called the base. Then we can also have things that look like this. 4, and then you might have the radical sign, right, with the 3 outside, but then a 22x on the inside. Let's talk about what each of those parts is called. So the 4 would be called a coefficient. This 3 is the index. Sometimes they'll call it like a root as well, like a square root or a cube root. This funny division looking sign is called a radical sign. And that makes whatever's inside that radical sign a radicand. But now for Algebra 2, we're going to look at fractions as exponents. And so you have to take all of the rules that you learned about about fractions back in like 4th and 5th grade and be able to use them when you have an exponent that is a fraction. So before each explanation, I'm going to review how to deal with fractions for that section as well. So first of all, when you have a fraction as an exponent, it is representing a radical sign like this. So let's see what that looks like. So if you have a to the 1/6, right? So now we have a fraction as an exponent. That really means that you're taking the 6th root of a to the 1st. And you can put the 1 there for the a to the 1st, but also it does not have to be there, right? We don't always put those invisible ones. An example, just another example, right? If we did it again, if you had x to the 2/3, then that is the same as taking the cube root of x squared. And so about 7 or 8 questions, 7 questions on your test are just, can you go, if I give you this, can you write this? Or if I give you the radical sign way, can you write it as a fraction, a fractional exponent, right? So let's try it that way. If you have the 8th root of 2 cubed, putting that as a fractional exponent, it's still going to be 2 cubed. So you're going to have 2 to the 3rd power over 8. The biggest mistake people make on these is that they just mix it up. They'll put the 3 outside and the 8 inside. It's really important that the denominator ends up being on the little shelf of the radical sign. Let's practice again. If we had the 4th root of 3 squared, writing that as a fractional exponent would be 3 squared over 4. But now we do need to reduce. So let's make sure we write the word reduce. And let's look at what that would look like. We can divide by 2/2. 2 divided by 2 is 1. 4 divided by 2 is 2. So our finished answer, right, our simplified answer would be 3 to the 1/2. Now, one way they might mess you up a little bit is that they're going to say, okay, so if you have the 3rd root, right, cube root of a to the 4th power, well, that's going to be a to the n. And they'll say, what does n equal, right? Find n, tell me what n equals. So here you need to be careful because we need to know that this is really a to the 4th power over 3, right? We create that fraction. But if you write this as your answer, it will be wrong because the question is only asking what n equals, and n equals 4 over 3. So just be careful if they do that too, right? Another thing is, if they gave you what is a, the square root of a to the 5th power, what would that fraction be like? Well, we've got a to the 5th power over, what would it be over? What is invisible and sitting on the little shelf here? What is the index of this root? Well, it is a square root, so there is an invisible 2 out here. It's invisible because if there's nothing, we always just assume it's a square root. Square root is the one that you learned first, like in middle school, square root of 9 is 3, square root of 25 is 5, those kinds of things. So this would have to be 5 over 2. And again, if they were asking you what n equaled, you would just do the fraction of 5 over 2. Okay. And then let's give a little divider and we'll start our next section. So before we start the Algebra 2 part, let's review adding fractions. An important part of adding fractions is that you need common or the same, right, denominators. So let's put that little reminder out here. So if you have 2 over 3 plus 4 over 3, you add the tops, and the 3's, since they are the same, get to stay the same. If the 3's are not the same, you have to do a bunch of work to get a common denominator. I did not give you one like that on the test, so I'm not going to do that for you here. But so since we have like denominators, we just add the top. 2 plus 4 is 6 over 3. And then you have to check if you can reduce, which we can. I can reduce by dividing by 3 over 3. If you're struggling with figuring out what to reduce by, one thing you can do is just start with, are they both even numbers? If they're both even numbers, you can divide by 2 over 2. Then I check 3 over 3. Can I divide by 3 over 3? Does the top number evenly divisible by 3? Is the bottom number evenly divisible by 3? And then I'll check 4. I will check 5. And then it's usually not more than that. So I check 2, 3, 4, and 5, and then I let it go. 6 divided by 3 equals 2. 3 divided by 3 equals 1. 2 over 1 is just 2. So now the question is, when would you use this, right? Well, you would use this if we were doing the product, which means multiply, right? Multiplication. The product of powers or exponents, right? If it's, if it's raised to the power, right? It's power of something. So we've got the same base, right? So if you're multiplying the same base, we're going to write it different color, nice and big, add exponents. And like, this is where it really gets algebra 2-ish, right? Because you're multiplying your bases, but that means you add your exponents. Your brain really has to shift back and forth between adding and multiplying. So let's go. If we had x to the 2 over 3 times x to the 4 over 3, these are the same base, right? So we're going to add the exponents. So I would write it like this, x to the 2 over 3 plus 4 over 3. We have like denominators, common denominators, so I can just add. So we'll get x to the 6 over 3. And then we have to reduce. So I divide by 3 over 3, that equals 1/2. Notice I'm using the exact same fractions that I did in my practice of adding fractions, right? Just using the same example. So that would give us x to the 1/2. My bad. Oh, I hate when I make mistakes. All right. Sorry, going too fast. 6 divided by 3 is 2 over 1, which gives us x squared. Oof, this is ugly. I wish I could edit. If I could edit, I would start that part over and I would be like x to the 6 over 3. Let's reduce. We're going to divide by 3 over 3. 6 divided by 3 is 2. 3 divided by 3 is 1. 2 over 1 equals 2. So we get x squared. Phew. Someday I'll go and edit that. Not today. All right. And then you need to know the name product of powers because there is a question on the test that's like, which rule or which law or which property did we use? So if you multiplied something and added the exponents, you're going to cite that you use this proper product of powers property. All right. Now let's do a power to a power, right? So let's practice multiplying fractions. So multiplying fractions. So let's start with our practice of 5 over 4 times 2 over 3. Now multiplying fractions is lovely because you can just multiply the tops together and then multiply the bottoms together. So 5 times 2 is 10. 4 times 3 is 12. But then you have to reduce. Let's see, they're both even, so I know I can divide by 2 over 2. Sometimes I'll check, if 2 over 2 will work, I'll also check 4 over 4 in case more than one can go in. 10 divided by 2 is 5. 12 divided by 2 is 6. And that would be your answer. Or let's make sure we show you another way how to do it. So another way we could do it is we could do the same problem. 5 over 4 times 2 over 3. And you can reduce right here. We can see that 2 goes into 2 once and 2 goes into 4 twice. Or that 2 divided by 2, right? This step that we did here, we can just do it here. 2 divided by 2 is 1. And then 4 divided by 2 is 2. Now when we multiply, we'll get 5 times 1 is 5, and 2 times 3 is 6. Check it out. Doesn't matter how you do it. You get the same answer. Okay? Hopefully you still have room on your page to do the next one, but I do not, so I have to go to the next page. And this is where we're going to practice the property of power to a power. And this one will always have parentheses. So if you have a problem on a test and it's got parentheses on it, you can look over here and see if it fits this rule, right? So power to a power always has parentheses. Our example that we're going to play with is x to the 2 over 5, all of that to the 3 over 4. And then I almost always put a little multiplication dot there to remind myself that we are going to multiply those exponents. Okay, we have a power to a power, so we're going to multiply. We just practiced multiplying exponent or multiplying fractions, so that's what we're going to do here. So this is going to equal x to the 2 over 5 times 3 over 4. Now, again, you could reduce now. I could see that the 2 goes into the 4 and I could reduce that. But I'm going to wait to reduce just because that's how we've been doing it so far. So 2 times 3 equals 6. 5 times 4 equals 20. And now we're going to reduce. We can see that they're both even numbers, so I can reduce by 2 over 2. 6 divided by 2 equals 3. 20 divided by 2 equals 10. So our answer would be x to the 3/10. Now, exponents do get a little more complicated than this power to a power rule. So let's talk about a bonus power to a power rule. Now, this is bonus on our poster that we did, but it is not bonus for your test. It will be on your regular Module 6 test. So this one is still power to a power, but it's if you have more variables or coefficients inside of those parentheses. So if we had 2x to the 1/2, y to the 2/3, all of that to the 2/5, we have to work out how we would handle that, right? So again, I'm going to put my dot here for multiplication, but then I'm also going to put those little rainbow lines to remind myself I have to multiply the exponent times the exponent on the y, the exponent outside the parentheses to the exponent on the x, and the exponent on the outside of the parentheses to the exponent on the 2. And if you're sitting there going, Ms. Hefko, there are no exponents on the 2. There is an exponent on the 2. We have an invisible 1 there. Okay. So that means we're going to get 2 to the 2/5, because 2/5 times 1 is 2/5. Then we're going to get x to the 1/2 times 2/5, right? Because a power to a power, we multiply just like we multiplied here. And then we're going to do y to the 2/3 times 2/5. Again, because a power to a power, we multiply, we're multiplying just like we did there. So 2 to the 2/5 just stays. X, now let's multiply. 1 times 2 is 2. So we get a 2, and then 2 times 5 is 10. Again, if you see that you can reduce there, you could have reduced already. We will reduce in the next step. Both of them work. They get you the same answer. Then we have y to the 2/3 times 2/5. So 2 times 2 is 4. 3 times 5 is 15. And then we think about, can that be reduced? They're not both even. 3 does not go back into both of them. 4 does not go into both of them. So we're done. They won't reduce. But the 2/10 will. I'm going to reduce the 2/10 off to the side here just for space. Reduce. So we have 2/10 divided by, think about what you can divide by. They're both even, so we can divide by 2/2, and that'll give us 1/5. So our final answer is 2 to the 2/5, x to the 1/5, y to the 4/15. Next, we're going to practice subtracting fractions. So back to 4th grade, we're going to subtracting fractions. So our example is, what if you had 7/5 minus 3/5? So let's write again on the side that we need common denominators. If you don't have common denominators, you have to make them. Again, I don't give you one like that on the test, so I'm not going to review it here. All right, so 7 minus 3 is 4. Our denominators are alike, so they get to just stay alike. We get 4/5. So now let's see what that would look like if we had quotient of powers. And so let's remind ourselves that quotient means we have to divide. It's the answer to a division problem, right? Quotient is. Okay. So if problem was x to the 7/5 over x to the 3/5, then that would equal x to the 7/5 minus 3/5. Because we learned that back when we did the laws of exponents, that when you're dividing, you subtract the quotients, the exponents. So we're subtracting the exponents. That gives us x to the 7 minus 3 is 4 over 5. And then there's nothing I can reduce there, so we're done. All right. Now let's try the bonus quotient, right? So bonus quotient to a power is when you have more than just one thing, right? Oh, my bad. I skipped something. Okay, we did quotient of powers. Let's do power of quotients first. So I'm going to turn the page again so that I have more stuff. We will do that one in a second though. So if you already wrote it, just hold on. Okay, so let's do now, what if we have power of quotients, right? So we have a quotient and then it's raised to a power. So you'll have parentheses. So always has parentheses. So now you have two places you can look if you have parentheses, right? To check and see if it's this property you're using. So if we have x to the 5 over 2 all over x to the 4 over 2, this is telling us it's a quotient because this is division. But then you have all of that in parentheses and raised to the 2/3. Let's see what you do. So we have a power to a power. So I'm going to put my multiplication dot in there to remind myself. I'm going to put my rainbow in to remind me that I have to distribute to that one, right? I multiply those two exponents, but I also multiply those two exponents. So we're going to get x to the 5 over 2 minus 2, my bad, times 2 over 3 all over x to the 4 over 2 times 2 over 3. And you could have subtracted first if you wanted to, but I don't want to teach too many ways today, so we'll do this one. So now I can multiply across. 5 times 2 is 10, 2 times 3 is 6, so I get x to the 10 over 6, and then x to the 4 times 2 is 8 over 2 times 3 is 6. I can absolutely reduce these, but I don't want to yet because right now I have like denominators and I love that. So let's keep those like denominators so that I can go x to the 10 over 6 minus 8 over 6. Excuse me. And then we get x to the 10 minus 8 is 2. And then we need to reduce. Divide by 2 over 2 equals 1/3. So our answer is that it equals x to the 1/3. So now I'm going to go back and do that bonus quotient to a power where I put more things inside the parentheses so that you get practice of really distributing out that exponent on the outside to everything inside. All right, so the bonus one, it's going to be a lot. We've got 2 x to the 1/3 y to the 3 over 2 over 3x to the 2/3 y to the 1/2, and then all of that to the 1/4. And of course, as you go, you should be pausing to get caught up or whatever you need. All right. I like to put my dot in there to remind myself that I'm going to multiply. And then you can also put your rainbows in, but be careful with your rainbows that you don't cover up any numbers and make it hard to read, right? So mine are like really light. Remember, we have an invisible exponent of 1 on both of those whole numbers. All right, let's go. So we get we get 2 to the 1/4, right? 1/4 times 1, 1/4. X to the 1/3 times 1/4. Then y to the 3/2 times 1/4, all over 3 to the 1/4, x to the 2/3 times 1/4, y to the 1/2 times 1/4. Don't be afraid to, make sure your pencil is super sharpened for these, or write a whole lot bigger, because mistaking a 3 for a 5 will ruin the whole problem, right? So we want to be really careful. So we're going to stay with 2 to the 1/4 over 3 to the 1/4. We're going to just leave those. And then we've got x to the 1 on the top over 12 on the bottom, right? 3 times 4 is 12. And then y, 3 times 1 is 3 for the top, and then 2 times 4 is 8 for the denominator. Doing the denominator here, we've got x, 2 times 1 is 2, over 3 times 4 is 12. And then y, 1 times 1 is 1, over 2 times 4 is 8. This one is good. It looks like an exponent. This one's getting a little worrisome. It should be higher and smaller. But that's a little rough when we're writing so much, you know? So now I need to subtract any that have like bases. My 2 and my 3 are not like bases, so those are actually going to stay just as they are. 2 to the 1/4 and 3 to the 1/4. But now my x, I can do x to the 1/12 minus 2/12, right? Because our quotient of powers rule is that we can subtract the denominator from the numerator. And then we have y to the 3/8 minus 1/8. Okay. So then this is going to equal 2 to the 1/4, x to the negative 1/12, y to the 2/8, all over 3 to the 1/4. We're not allowed to have a negative exponent, right? So if you look at your laws of exponent notes, it says that we can take this whole thing, the x to the negative 1/12, and put it on the other side of the fraction bar, right? Put it from the numerator into the denominator, and then the exponent will become positive. So let's do that. 2 to the 1/4 over 3 to the 1/4, x to the 1/12. Notice it's a positive 1/12 now. And then the y will stay on top, but it should not be to the 2/8 because we should reduce. Divide by 2 over 2 because they're both even, and we get 1/4. So that'll be y to the 1/4. And that is your final answer. All right. I'm going to go on to do the Module 6 test practice. So these are ones that I did on the whiteboard. So lots of people do not have them in their notebook. But for my people who were absent or anybody who wants the review, here we go. So there are I don't know, 7 or 6, 7 points that are based just on this idea that if we have 68 to the 9/5, how could you write that in radical form? So you want to remember that the 5 becomes the denominator, becomes the index. So that goes out on that little shelf. And then the 68 to the 9th power stays under the radical sign. That's it. There's a bunch of questions on that you get the points just for that. So we practice that in class a lot. So try a few of them. The most common mistake is that people will put the 5 as the exponent and the 9 as the index, and then you miss the whole problem. So take the time when you take the test to check your notes and make sure you're doing it right, okay? Then they'll also do it the other way. They'll give you a problem like this, the 11th root of 3.8 to the 5th power. and they want you to do it as a fractional exponent. Well, that's just going to be 3.8 to the 5th power over 11. Again, the most common mistake is that you flip the numerator in the denominator, the exponent in the index. So you just have to check your notes and make sure you're doing it right. Okay. All right. Next one. If you have a to the 2/5, b to the 2/7, c to the 4/9, all of that to the 5th power, how would you handle that? So copy it down, think it through. So I'm going to start with my dot, right? To remind myself that this is multiplication. I'm also going to remind myself that I multiply times everything, all of the exponents inside. So that's going to be the same as a to the 2/5 times 5. When I have a whole number like 5 and I'm multiplying times a fraction, I like to change my whole number into a fraction also. So I'm going to multiply times 5/1 for everything. So then I have b to the 2/7 times 5/1 and c to the 4/9 times 5/1. 2 times 5 is 10, so we have a to the 10 over, and then 5 times 1 is 5. Ooh, I could have reduced. That would have been so pretty. I could have just reduced there the 2 5s, ended up with a 2. It would have been gorgeous. But we'll reduce and get the same. Then I have b, 2 times 5 is 10. 7 times 1 is 7. And then we have c, 4 times 5 is 20. 9 times 1 is 9. This one's an odd and an even, and they are not divisible by 3, so that one will not reduce. 10 and 7, an odd and an even, so can't reduce by 2, can't reduce by 3, that one's not going to reduce. But 5 and 10 can reduce. So I'm going to just make a little note over here that I am reducing 10 over 5. What can I divide both the top and the bottom by so that it reduces? Yeah, we're going to reduce it by 5 over 5. So 10 divided by 5 is 2. 5 divided by 5 is 1. 2 over 1 is 2. So this a to the 10 over 5 is just going to change to be a squared, b to the 10 over 7, c to the 20 over 9. Next one, I'm going to give a little division line to help my brain focus. If we have the cube root of m squared, oh my, I'm starting over. If we have the cube root of m squared n to the 6th, all of that times the cube root of m to the 5th n to the 3rd, how would we handle it? Where would we start? Because they are both to the same root, we can combine them, or they have the same index, right? So we can do cube root of m squared m to the 5th n to the 6th n to the 3rd. And we are multiplying all of those. And our rule for multiplying with the same base is that we add the exponents. So I'm going to do cube root of m to the 2 plus 5, n to the 6 plus 3. In our notes, we always write this step out. If I were just doing a test or a quiz and I'm confident, I could just add those in my head. I wouldn't have to write the step. So then let's do cube root of m to the 7th, n to the 9th, because 2 plus 5 is 7, 6 plus 3 is 9. Now, let me just remind us of what a cube root does, right? So if we have a cube root of 27, that equals 3. The reason it equals 3 is because 3 times 3 times 3 equals 27. 3 times 3 is 9. 9 times 3 is 27. So since we have a group of 3, the answer without the radical sign is 3. Okay, I really do apologize for the focusing. I should find a better way. All right. So here I would like to find how many groups of 3 I have. So one way to do it is to write it all out. So if we have the cube root, and then I have 7 m's in here. I've got m times n times n times n. And I have 9 n's. So right, so I have the cube root of all of those. So I'm going to go ahead and group them by 3's. So I have 3 m's. So that means I'm going to take an m outside of this cube root. Ooh, and then I have another set of 3 m's. So now that's going to be squared because I have m and another m times m is m squared. And then I just have one left. So he stays under the radical sign. Then we do the same thing to the n's. So I have one group of 3 n's. The answer to that, it's going to be an n that gets to be on the outside of the radical sign. Then we have another n, because I have a group of 3. Ooh, and then I have another group of 3. N times n is n to the third power with none left over underneath. That's it. All right, I'm out of room, so I'm going to turn the page. The next one is working on those quotients again. So if we have 5 square root of x to the 4th over 10 square root of y to the 3rd, what can we do with that? Well, the 5 and the 10 can be reduced. So let's start there. 5 divided by 5 is 1. 5 divided by 10 is 2. Sorry, 10 divided by 5 is 2. So that's going to give us 1 over 2. Now our x to the 4th, we're taking the square root. So remember, there's an invisible 2 out here. If there's nothing written, it's the square root. So that means I have x times x times x times x inside there, right? We have 4 of them, x to the 4th. And now I can group them. I'm going to group them by 2's, right? In pairs. So there's an x and there's an x. So we get 1x squared. And there's nothing left under the radical sign, so I don't need the radical sign anymore. Down here, we have y times y times y. And so I can take out a pair. And so I would get y, and then we would have 1 left over under the radical sign. Small problem. We're not allowed to have a radical sign in the denominator, so we have to rationalize this expression. So we're going to rationalize by multiplying times square root of y over square root of y. We do that because now I have y times y. I have the square root of y squared, which equals y. This y multiplies times that y, and that would equal y squared. So I end up with 1 over 2 y squared. And on the top, I still have my x squared. And now I have a square root of y up there. And that's how it stays. And I actually don't need to write this one. Math people would probably prefer that I didn't, but there it is. Okay. Let's do another one of those that I did at the beginning, just to see if we remember which way it goes. If we have the seventh root of m to the third, how would I write that with a fractional exponent? Ooh, and let's do it the tricky way. What if it said equals m to the n? What would your answer be? Yeah, your answer is going to be that n equals 3 over 7. 3 over 7. Again, because if you were writing it here, it would be m to the third, that part stays, and then over 7. Next one. If we had a real number like 27 to the 5 over 2, all of that to the 2/3, how would we handle it? Well, we're going to start by multiplying, right? Multiplying our exponents. So this means I get 27 to the 5 over 2 times 2 over 3. I think I will go ahead and reduce here. I see that I have a 2 on the top and a 2 on the bottom, so they just cancel. So that equals 27 to the 5/3. Now, because I have a real number, 27, right? Not a variable that I don't know what the number is, I should write this in radical form. So I'm going to go cube root of 27 to the 5th power. We showed two ways of doing this. You could do 27 to the 5th power first and write that really, really big number under the cube root, and then try to figure out what the cube root of that really big number is. But it would be nice if you notice that 27 is a perfect cube. How do you notice these things? You look at them in the back of your notebook, right? Where we have all of our perfect cubes. And so I see that 27 is on here. So the cube root of 27 is 3. So this equals 3, but still to the 5th power. If it is squared or to the 3rd power, you need to do the math. If it's to the 5th power, you should ask. So we're going to go ahead and work this out. So I'm going to go two choices. You can go 3 times 3 times 3 times 3 times 3. So there are 5 of them. You can't see it, but there are 5 of them, I promise. And that equals 243. Or clearing it out, you can go 3, and then we have this x to the exponent that's blank, and I can put a 5 in there, equals, and it's still 243. Right on. Next one. All right. So then we have kind of a weird one that's like, if you have y equals 3 times the quantity x cubed minus 6, can you solve it for x? So I want to get x by itself. The best way to start would be to divide both sides by 3, because then the 3 will be moved already. However, when we asked in class, most kids, their first reaction, their first thought to do was to multiply the 3 times everything inside. And that will also work. So I will do it that way. All right. So we get y equals 3x to the 3rd minus 18. 3 times 6 is 18. I need the x by itself, so I want to get rid of other stuff first. I'll get rid of the negative 18 by adding 18 to both sides. So now I have y plus 18 equals 3x cubed. Now I need to get rid of the 3 by dividing each term by 3. So we get y divided by 3 plus 6 equals x cubed. So to get x by itself, I need to take the cube root of x cubed. So that'll give me x over here. But then I also need to take the cube root of this whole side. So we get the cube root of y over 3 plus 6. But then there's a second part of this problem that's like, what if, right? What if y equals 174? So then you just plug y, 174, in for y that we have here. So let's do that. Let's do the cube root of 174 divided by 3 plus 6 is going to equal x. 174 divided by 3 equals 58. So we get the cube root of 58 plus 6 equals x. We get the cube root of 64 equals x. And it would stay like that, except that we need to check our cube root chart, right? And cube root of 64 does equal a nice pretty number. So let's do cube root of 64 equals 4. There you go. And this one will not be plus or minus 4 because it has an odd index, right? Square root, we would be using plus or minus, but a cube root, it has to be either positive or negative. Okay, we have one problem left. One problem left. Let's do it. All right. Oh, I haven't been doing this the whole way through. I'm so sorry. But if it helps your brain, this one is like number 15 on the test. And it is, if you have 2x to the 1/8, y to the 9/15 times 5, y to the 1/15, z to the 3rd, and then 7x to the 2/7, z to the 5th power. How would you handle that? All right. So what we're going to start with first are all of our whole numbers. So we're going to do first grade numbers first. So our first grade numbers are 2, 5, and 7. So we're going to write 2 times 5 times 7. 2 times 5 is 10. 10 times 7 is 70. And then we are multiplying, right? This is all multiplication. So we're multiplying the same base. So an x times an x. What do I do with the exponents when I'm multiplying the bases? We add the exponents. So then we've got x to the 1/8 plus 2/7. Oh, that is very ugly for having to add those fractions. But we'll do it. We'll be fine. Then we have y to the 9/15 plus 1/15, right? There's another y. No y's over there. Then we also have the variable z to the 3rd plus 5. Okay. So that's going to give us 70. And then x, I'm going to do this math off to the side. So if we have 1/8 plus 2/7, I need to have the denominators be the same. So if I multiply them both by 2, it's going to give me, what, 16 and 14? That's not the same. I could check a bunch of numbers, but I know that I have to multiply this one by 7/7, and I have to multiply this one by 8/8. 1 times 7 equals 7 over 8 times 7 equals 56. 2 times 8 equals 16. 7 times 8 equals 56. So now I have like denominators, I can just add them together, right? So here we go, 7 plus 16 is 23/56. And then I check to see if I can reduce. I cannot, they're not both even, so I can't reduce by 2. The digital root of 23 is 5, so I cannot reduce by 3. Can't reduce by 4 if you can't reduce by 2. Can't reduce by 5. Yeah, so I think it's reduced. 23/56. Then we have y to the 10/15 And then z to the 8th, right? Because 3 plus 5 is 8, 9 15ths plus 1 15th is 10 15ths. We checked 23 over 56, we cannot reduce. 10 over 15, can we reduce? They are not both positive, so I cannot, or sorry, they are not both even, so I cannot reduce by 2. Cannot reduce by 3, because 3 will go into 15, but not 10. If you can't reduce by 2, you cannot reduce by 4. But I can reduce by 5. So let me do that over here real quick. 10 over 15 divided by 5 over 5 equals 2 over 3. So our final answer will be 70x to the 23 over 56, y to the 10 over 15, z to the 8. There you go. Nice job. That's the end. Good luck.